What if our solar system was never alone? What if something from far, far away already visited us? Twice. My name is Dr. Marcus Reed, and I'm going to tell you the most amazing, incredible, unbelievable story that ever happened to me. It's a story that changed everything I thought I knew about space, about Earth, and about whether we're truly alone in this giant universe. I used to believe space was quiet and empty, just planets, stars, and rocks floating in darkness. But then the first messengers arrived, and I learned something that made my heart beat faster and my hands shake. The quiet had been watching us all along. Let me take you back to October 2017. I was just finishing college, studying to become an astrophysicist. That's a scientist who studies space, stars, and everything beyond Earth. It was a regular Tuesday morning. I was eating cereal and reading space news on my tablet, like I did every morning. Then I saw a headline that made me stop chewing. Mysterious object from interstellar space detected. My heart jumped. Interstellar means between the stars. Something from outside our solar system? That had never happened before. A scientist named Dr. Karen Meach was working at a telescope in Hawaii. She was looking through data when she spotted something strange. Something was moving through our solar system. Something that didn't belong here. Something from somewhere else. The object was already past Earth when we discovered it. It was heading away from the sun, moving incredibly fast. Scientists called it ʻOumuamua, ʻOumuamua. It's a Hawaiian word that means scout or messenger sent from the distant past. I thought that was the perfect name. I followed every article, every update, every scientific paper about ʻOumuamua. I couldn't stop thinking about it. ʻOumuamua looked like a long, reddish rock tumbling through space, but it wasn't shaped like normal asteroids or comets. Those are usually round or lumpy, like potatoes. ʻOumuamua was long and thin. Some scientists said it was shaped like a cigar. Others said it looked more like a giant pancake standing on its edge. Either way, it was about as long as a football field, but much narrower. It was spinning as it moved, tumbling end over end through the darkness. But here's what made scientists really confused. ʻOumuamua did something rocks aren't supposed to do. It sped up, all by itself, like it had tiny engines pushing it forward. Maybe it's a comet, some scientists said excitedly. Comets speed up when they get close to the sun because ice on them turns to gas, creating a natural rocket boost. But here's the problem. Comets have tails. Beautiful, glowing tails made of gas and dust streaming behind them. ʻOumuamua had no tail, none at all. Maybe it's just space junk, other scientists argued. Maybe it's a piece of a broken planet from another star system. But it was shaped too perfectly, too smooth, too unusual. Then a famous scientist from Harvard named Dr. Avi Loeb said something that made news channels around the world go crazy. What if it's artificial, he said. What if someone made it? What if it's a solar sail sent by an alien civilization? A solar sail is like a giant mirror that catches sunlight to push a spacecraft forward. It's technology humans are working on right now. Could ʻOumuamua be alien technology? Most scientists said no. They said there had to be a natural explanation, but some scientists weren't so sure, and neither was I. I spent hours thinking about ʻOumuamua. I had so many questions buzzing in my head like bees. Where did it come from? How long had it been traveling through space? Thousands of years? Millions? Why was it shaped so strangely? Why did it speed up? Was it really just natural forces, or was there something more? And the biggest question of all, if it was sent by someone, what were they trying to tell us? Before we could study it more carefully, before we could send a spacecraft to catch up and take pictures, ʻOumuamua zoomed away. It left our solar system and disappeared into the vast darkness between stars. Gone. Just like that. I felt sad, like we'd missed our chance, like someone had knocked on our door but we opened it too late. I kept a picture of ʻOumuamua on my wall. Every night before bed, I'd look at it and wonder, if that was a message, what was it trying to say? I never imagined I'd get a chance to find out. Fast forward to 2025. I'm now Dr. Marcus Reed, a real astrophysicist working at a research center in California. My job is to study objects in space. and figure out where they came from and what they're made of. It's like being a detective, but instead of solving crimes, I'm solving mysteries about the universe. I work with an amazing team. There's Dr. Sarah Kim, who's brilliant at math and can calculate anything in seconds. There's Professor James Wright, who's been studying space for 40 years and knows more about comets than anyone alive. And there's my best friend, Dr. Alex Martinez, who builds and programs the computers that analyze space data. We all work in a building filled with huge screens showing space images, computers humming, and the smell of coffee always in the air. It's my favorite place in the world. Even though 8 years had passed, I never stopped thinking about ʻOumuamua. I kept all the research papers. I joined online groups where scientists shared theories about what it might have been. Some people thought I was obsessed. Maybe they were right. "You need to let it go, Marcus," Alex would tell me. "It's gone. It's never coming back." "I know," I'd say, "but what if something else comes?" Alex would just shake his head and smile. The odds of that are millions to one. But I kept watching, kept hoping. And then, on a cold morning in March 2025, it happened. I was at my desk, working on data about a regular asteroid, when my computer started beeping loudly. Beep, beep, beep! A red alert flashed on my screen. Interstellar object detected. My coffee mug slipped from my hand. It hit the desk and splashed everywhere, but I didn't care. I jumped out of my chair so fast it rolled backward and crashed into the wall. "Alex!" I shouted. "Sarah! Professor Wright! Get in here!" They came running. When they saw my screen, they froze. "No way," Sarah whispered. "Is that—" Alex couldn't finish his sentence. Professor Wright put his hand on my shoulder. His voice was shaking. "We need to alert everyone. Right now, another visitor had entered our solar system. Another object from between the stars. This time we were ready. This time every telescope on Earth turned to look. The new visitor was officially named 2I/Borisov at first, but everyone started calling it 3I/Atlas after more observations confirmed it was different from the previous interstellar comet. Atlas was bigger than ʻOumuamua, brighter, and it was moving faster like it was in a hurry, but there was something even more amazing about Atlas, something that made my skin prickle with excitement and a tiny bit of fear. Our machines picked up strange signals coming from it, not radio signals like TV or phones. These were different. Electromagnetic pulses, beeps and patterns, over and over again. "It's just natural," Professor Wright said, adjusting his glasses nervously. "Space makes all kinds of electromagnetic noise. Solar wind, magnetic fields, cosmic rays." Sarah was staring at the patterns on her screen. Her eyes were wide. "Marcus," she said quietly, "look at these numbers." I looked, my breath caught in my throat. The patterns were made of prime numbers: 2, 3, 5, 7, 11, 13, 17, 19. Let me explain why this is so incredible. Prime numbers are special numbers that can only be divided by themselves and 1, like 7 can only be divided by 7 and 1, or 13 can only be divided by 13 and 1. Prime numbers are like nature's secret code. They're special in mathematics. They're not random. If you wanted to show intelligence, if you wanted to prove you could think and calculate, you might use prime numbers. Because prime numbers don't happen by accident in nature. "This has to be natural," Professor Wright insisted. "It has to be. Maybe it's just ice crystals creating interference patterns or magnetic fields interacting with solar wind." But his voice didn't sound confident. It sounded scared. We watched Atlas for days. More telescopes joined in. Space agencies from America, Europe, China, Russia, Japan, and India all pointed their instruments at our visitor. Then, on the 5th day, something incredible happened. The sun had a solar flare. A huge burst of energy exploded from the sun's surface and rushed outward into space. It's something that happens sometimes. Usually it just creates beautiful auroras on Earth. But this solar flare was aimed right at Atlas. The hot, bright energy hit Atlas like a wave hitting a beach, and Atlas changed direction. Just slightly, just a little bit, but enough for us to measure it. "It's responding to the solar environment," Professor Wright explained. "The pressure from the solar flare pushed it. That's normal physics. But to me, it looked different. It looked like Atlas had heard something and moved on purpose, like it was answering. I got goosebumps all over my arms. 2 visitors, both strange, both from beyond our solar system, both doing things that seemed impossible. Were they connected? Was the second one answering the first one? I grabbed Alex's arm. We need to compare them. ʻOumuamua and Atlas. Every piece of data we have. Everything. Alex nodded. I'll start running the programs. But Marcus, he looked worried. What if we find something? Then we'll know the truth, I said. What I didn't say was I'm terrified of what that truth might be. Within a week, everything changed. The news was everywhere. Every TV channel, every website, every phone notification, everyone was talking about Atlas. Is it aliens? Second interstellar visitor detected. Are we being watched? Some people were excited. Some were scared. Some didn't believe it at all, but the scientists believed it. And more importantly, the governments believed it. Countries from all around the world came together. America, China, Russia, the European Union, India, Japan, Brazil, and dozens more. They created something special. Project Messenger. The goal was simple but huge. Study both visitors, figure out what they were, and if they were sending a message, understand what it said. They needed the best scientists in the world. Astronomers to track the objects, physicists to understand their behavior, mathematicians to decode patterns, linguists to look for language, computer scientists to process all the data, and they needed someone who had been studying ʻOumuamua for 8 years, someone who knew everything about the first visitor. They needed me. I was eating dinner when my phone rang. It was a number I didn't recognize. Hello? Dr. Marcus Reed, a woman's voice, official sounding. Yes, this is Director Patricia Chen from the International Space Coordination Office. We need you in Geneva, Switzerland, tomorrow. You've been selected for Project Messenger. My fork clattered onto my plate. What? Tomorrow? Pack for 3 months. Bring all your research on ʻOumuamua. A car will pick you up at 6 a.m. This is urgent, Dr. Reed. Humanity needs your help. She hung up. I sat there, staring at my phone, my heart pounding like a drum. Alex and Sarah got calls too. So did Professor Wright. We were all going. That night, I couldn't sleep. I packed my bags, printed out all my notes, and watched the stars through my window. Somewhere up there, Atlas was moving closer. And somewhere beyond everything, ʻOumuamua was still traveling. Tomorrow, I will start trying to understand what they wanted to tell us. The next morning, a black car picked me up. The driver didn't talk. He just drove me to the airport, where a private plane was waiting. On the plane, I met the other scientists, 50 of us from around the world. Everyone looked nervous and excited. We flew to Geneva and were driven to what looked like a normal office building, but we didn't stop there. The cars drove around back and down into an underground parking garage. Then we went down further and further. We were led into an elevator that went down for a full minute. When the doors opened, I gasped. We were in a massive underground facility. It looked like something from a movie. Giant screens covered the walls, showing live images of Atlas. Hundreds of computers, workstations everywhere, people in white lab coats rushing around. In the center of the room was a huge hologram projector showing a 3D model of our solar system, with both ʻOumuamua's path and Atlas's path marked in glowing lines. Welcome to Project Messenger, Director Chen said. She was a tall woman with sharp eyes and grey hair pulled back in a bun. You're here because you're the best in the world at what you do. What we discover here will change human history. Let's get to work. They assigned me to Team Alpha, focused on analysing the similarities between ʻOumuamua and Atlas. Sarah and Alex were with me. Professor Wright was assigned to Team Beta, studying Atlas's current behaviour. For the first week, we barely slept. We worked 18-hour days, eating sandwiches at our desks, drinking terrible coffee from machines, and staring at screens until our eyes burned. But then we found something. It was 3 a.m. on the 8th day. Sarah, Alex, and I were the only ones left in our section. Everyone else had gone to sleep. Sarah was running a comparison program, checking thousands of data points from both visitors. Suddenly, the computer beeped. Match found, the computer said in a calm voice. We all jumped up and ran to Sarah's screen. There, displayed in green and blue, were two patterns. One from ʻOumuamua's trajectory and acceleration, one from Atlas's electromagnetic pulses. They were similar, very similar, like two songs written by the same composer, like two sentences written by the same person. "Oh my God," Alex whispered. My hands were shaking. "They're connected. They have to be. But how?" Sarah was already typing furiously. "I'm running a deeper analysis. If these patterns match, maybe there are more similarities we haven't found yet." We worked until sunrise. By the time other scientists started arriving, we had something incredible to show them. Both ʻOumuamua and Atlas carried encoded similarities in their data, not just one or two coincidences, dozens of them, like they shared the same code, like they came from the same place, like they were built by the same someone. Director Chen called an emergency meeting. Every scientist in the facility gathered in the main room. Sarah presented our findings on the giant screens. You could hear people gasping. "What does this mean?" someone asked. A scientist from India named Dr. Patel stood up. She specialized in astrobiology, the study of life in space. "What if these are like seeds?" she said. "Seeds that travel through space, spreading the materials needed for life. We know that comets brought water and organic molecules to Earth billions of years ago. What if ʻOumuamua and Atlas are doing the same thing, but intentionally?" The room went silent. Professor Wright stood up. "But seeds don't send signals. Seeds don't have patterns. These objects are doing more than just carrying materials." I stood up too. My voice came out stronger than I felt. "They're not just seeds. They're carrying information, like a message in a bottle floating through the ocean of space. The question is, what is the message saying?" Director Chen looked at me. "Then that's your job, Dr. Reed. Figure out what they're trying to tell us." The weight of those words pressed down on me like a heavy blanket. The fate of understanding might rest on my shoulders. For the next 3 weeks, I barely left my workstation. I ate. I slept a few hours on a cot in a side room. Then I woke up and worked again. I was obsessed. Everyone said so. Alex brought me food and made sure I showered. Sarah checked my work to make sure I wasn't making mistakes from exhaustion, but I couldn't stop. The answer was there. I could feel it, like a word on the tip of your tongue that you just can't remember. I analyzed every piece of data from both visitors. Their speed, their spin, their trajectory, their composition, the way light bounced off them, everything. And slowly, patterns emerged. Let me try to explain it in a way that makes sense. Imagine you're listening to a song. At first, it just sounds like random notes, but if you listen carefully, you notice the same melody repeating. Then you notice the rhythm. Then you notice how certain notes always come together. That's what I was doing with ʻOumuamua and Atlas, listening for the melody, looking for the rhythm. It was Sarah who figured out the next piece. She burst into our workspace one morning, her hair messy, her eyes red from not sleeping, but she was smiling bigger than I'd ever seen. "Marcus! Alex! I found something in Atlas's signals." She pulled up data on the big screen. Waveforms, electromagnetic patterns, numbers scrolling past. "Look at this frequency," she said, pointing. 7.83 Hertz. It keeps appearing over and over. "What's special about 7.83? I asked. Sarah grinned. "It's Earth's Schumann resonance. It's the natural frequency of electromagnetic waves in the space between Earth's surface and the ionosphere. It's like Earth's heartbeat. It's been measured thousands of times. It's always 7.83 Hertz. My mind spun. How would something from outside our solar system know Earth's frequency? "Exactly," Sarah said. Unless it measured it," Alex finished. "Unless it's been listening to Earth." We stared at each other. How long had Atlas been listening? How long had they known about Earth? And who were they? 2 days later, I made my own discovery, and this one made my blood run cold. I was studying the paths both visitors took through our solar system, their trajectories, where they came from in space, and where they went. I'd looked at this data 100 times before, but this time I added something new. I calculated where Earth was in its orbit around the Sun when each visitor passed through, and I saw something impossible. Both visitors entered our solar system at the exact same angle. Not similar, exactly the same, down to a tiny fraction of a degree. But that's not all. Both passed through the exact spot where Earth would be in its orbit. ʻOumuamua passed through where Earth would be 200 years in the future. Atlas passed through where Earth was 200 years in the past. They were bracketing us, marking Earth's position across time. That's not random. That's not an accident. That's not just statistics. Someone or something was aiming for us. I called an emergency meeting. When I showed everyone my findings, the room erupted. "This can't be right," someone shouted. "Check the math again," another person demanded. But Sarah checked it. Alex checked it. Professor Wright checked it. A team from MIT checked it. The math was right. We were being watched. We were being measured. We were being catalogued. That night, the facility was in chaos. Scientists arguing, some people crying, some people laughing nervously. The big question everyone was asking, what does this mean for us? Maybe we're being studied, Dr. Patel suggested, like how we study animals in the wild. They want to understand us without interfering. Or maybe we're being warned, a scientist from Russia said darkly. Maybe something dangerous is coming and they're trying to tell us. Or maybe, a young scientist from Brazil said quietly, we're being invited. Maybe this is first contact. Maybe they want to know if we're ready to join whatever is out there. Director Chen raised her hand for silence. Speculation isn't helpful. We need more data. Dr. Reed, keep working on decoding the patterns. Everyone else, keep analyzing Atlas. It's still in our solar system. We still have time to learn more. But time was running out. Atlas was moving fast. In a few months, it would leave our solar system too, and we might never get answers. I had to work faster. It happened on a Tuesday morning. I remember because I was eating a banana for breakfast. It was the first real food I'd eaten in days. Alarms started blaring throughout the facility. Atlas status change! Atlas status change! Everyone ran to the main screens. Atlas was breaking apart. On the screens, we could see it. The bright object was splitting into pieces, not exploding, not shattering, just separating like it was planned. Is it hitting something? Someone asked. No, Professor Wright said, checking his instruments. There's nothing there. It's just coming apart. My stomach dropped. Was Atlas dying? Was it damaged? Had our solar system's heat or gravity destroyed it? But then something even stranger happened. The pieces didn't scatter randomly like you'd expect from an explosion. They stayed in formation, moving together, creating a shape. Are you seeing this? Sarah asked, her voice barely a whisper. We were all seeing it. We just didn't want to believe it. The fragments of Atlas were forming an arc, a curve, like an arrow. And the arrow was pointing toward Earth. Within hours, the news leaked to the public. We never found out who told the media, but suddenly everyone on Earth knew. Atlas fragments point to Earth. Is it going to hit us? Scientists say impact possible. The panic was instant and terrible. Phone lines were jammed with people calling loved ones. Stores were mobbed with people buying food and water. Some people prayed. Some people protested outside government buildings. Some people just sat and cried. But the scientists knew the truth. The fragments were too small and too far away to hit Earth. They would burn up in space or miss us by millions of miles. This wasn't an attack. It was a message. But what was the message? Director Chen got on TV and tried to calm people down. There is no danger. The fragments cannot harm Earth. Please stay calm. But fear spreads faster than facts. Inside the facility, we worked frantically to understand what the arrow shape meant. Was it a warning, a threat, a direction? It was Alex who found the next piece of the puzzle. He'd been running Atlas's signals through every database we had, trying to find matches or similarities to anything humans had ever recorded. At 2 a.m., his computer beeped. Match found, Alex stared at the screen. Then he ran to wake me up. Marcus, wake up. I jerked awake on my cot. What? What's wrong? You need to see this, right now. We ran to his workstation. On the screen were two waveforms, two patterns of sound. One was from Atlas's electromagnetic signals converted to sound so we could hear it. The other was from the Voyager Golden Record. In 1977, NASA launched two spacecraft called Voyager 1 and Voyager 2. They were sent to explore the outer planets and then travel into interstellar space. On each spacecraft, NASA put a golden record, a disk with sounds and images from Earth. There were greetings in 55 languages, music from different cultures, sounds of nature, wind, birds, whales, images of people, cities, and landscapes. It was a message to anyone who might find the Voyagers, a message saying, "This is who we are. We are humans from planet Earth." And now, hidden in Atlas's signals, were pieces of that message. Not all of it, just fragments. A few seconds of music, a greeting in Chinese, the sound of a crying baby. They had found the Voyager spacecraft, they had listened to our message, and they were sending it back. "They heard us," I whispered. "They actually heard us." But there was something that made my hands go cold. The Voyager spacecraft launched in 1977. That was 48 years ago. They're now beyond the edge of our solar system in interstellar space. For someone to find Voyager, listen to it, and send a response back in the form of Atlas, they would have to be incredibly advanced and incredibly close, maybe only a few dozen light years away. Our neighbors had been listening all along. That night, we had the biggest meeting yet. Every scientist, every director, even some government officials joined by video call. The big question, what do they want? "Maybe they're copying us," suggested a linguist from France. "Maybe they're learning our language, like a child learning to speak by repeating what adults say." "Or maybe they're testing us," said a military advisor from America. "Seeing how we react, seeing if we're advanced enough to understand." Professor Wright raised his hand. "There's another possibility. Maybe they're proving they received our message. The Voyager Golden Record was us saying hello to the universe. This is them saying hello back." "But why send two objects?" Dr. Patel asked. "Why ʻOumuamua and then Atlas? Why not just one clear message?" I'd been thinking about this for weeks. Now I had an answer. "Because that's how you have a conversation," I said. Everyone turned to look at me. "Think about it. ʻOumuamua came first. It was strange and unusual, but it didn't do much. It was like someone tapping on your shoulder, getting your attention." I stood up and walked to the center of the room. Then 8 years later, Atlas arrives. But this time, there are signals, patterns, references to the Voyager recordings. It's like the second tap on your shoulder, but this time with a, "Hey, we're trying to talk to you." Sarah nodded slowly. So ʻOumuamua was a question. "And Atlas is the answer," I finished. "Or maybe the beginning of an answer." "Then what comes next?" Director Chen asked. No one had an answer. We were in uncharted territory. No human had ever been here before. We were having first contact, and we didn't know the rules. Atlas was leaving. Each day, it got further from the sun, further from Earth. Soon it would be too far away to detect its signals clearly. We had maybe 2 weeks left. I stopped sleeping almost entirely. I'd take 20-minute naps at my desk. Alex brought me coffee every hour. Sarah made sure I ate something, even if it was just a protein bar. The pressure was enormous. The whole world was watching, waiting for answers. Every news channel had countdowns. 10 days until Atlas leaves our solar system. 9 days left to decode the message. Kids at schools were learning about ʻOumuamua and Atlas. People were making art about them. Songs, poems, movies were being planned. And I was sitting at a desk, staring at numbers and waveforms, trying to understand what an alien intelligence was trying to tell us. Day 7, 1 week left. I was looking at the spectrum of light coming from Atlas. Every object in space gives off light, and by studying that light, we can tell what the object is made of. Different elements create different patterns in the light. I'd looked at this data before, but I hadn't looked closely enough. There, in the light spectrum, were peaks showing carbon, oxygen, hydrogen, nitrogen, phosphorus, and sulfur. These are called the CHONPS elements. They're the building blocks of life. All life on Earth is made from these 6 elements. But the amounts were strange. The ratios didn't match any natural rock or comet we'd ever seen. Then it hit me. The ratios matched Earth. Not exactly, but close. The amount of oxygen compared to carbon. The amount of nitrogen compared to hydrogen. It was similar to the ratios found in Earth's oceans and atmosphere. I ran calculations, I double-checked, I triple-checked. Then I called Sarah over. "Look at this," I said, my voice shaking. "It's a recipe." "A recipe for what?" "For planets. For worlds like Earth. The exact chemical ratios you'd need to build a planet that could support life." Sarah's eyes went wide. "They're telling us how to make worlds." "Maybe," I said. "Or maybe they're telling us how they found us. Maybe they searched the galaxy for worlds with these exact ratios. Maybe that's how they knew Earth was here." But there was more. I could feel it. This wasn't the whole message. Day 5. 2 days until we lost the signal. I wasn't alone anymore. 10 other scientists were working with me now, helping me go through every piece of data. We were looking at the final transmission from Atlas, the very last signal before it got too far away. Most of it was similar to what we'd seen before. Prime numbers, the Schumann resonance, pieces of the Voyager record. But at the very end, there was something new, something we almost missed. A scientist from Japan named Dr. Tanaka was cleaning up background noise from the signal when he noticed something. "Dr. Reed, there's a pattern here, in what I thought was just static." I looked. He was right. Hidden in what looked like random noise was a sequence of numbers. Not prime numbers this time, different numbers. And they came in 3 groups. 3 groups of numbers, 3 values. "Those look like coordinates," Alex said, leaning over my shoulder. My heart started racing. "Coordinates? In space?" We spent the next 6 hours converting the numbers, trying different systems, different approaches. Finally, we figured it out. Right ascension, declination, and distance. The 3 pieces of information you need to point to a specific location in 3-dimensional space. We plugged the coordinates into our star maps. The location was approximately 47 light-years away from Earth, in the direction of a constellation called Carina. We zoomed in on that region of space. There were several stars there, but one stood out, a yellow dwarf star, similar to our Sun. And according to previous surveys, it had planets. "That's where they came from," I whispered. "That's home." Director Chen called an emergency meeting of world leaders. For the first time in history, presidents, prime ministers, and leaders from every nation met together to make a single decision. Should we send a message back? The arguments were fierce. "We don't know if they're friendly," some leaders said. "What if we invite an invasion?" "But they haven't invaded," others argued. "They've just said hello." Isn't saying hello back the right thing to do? "What if there are different groups out there?" someone asked. "What if we make friends with one but enemies with another?" "What if staying silent is the biggest mistake?" another person said. "What if they interpret silence as hostility?" The debate went on for hours, days. Meanwhile, Atlas was getting further away. If we wanted to send a response while it could still hear us, we had to decide now. Finally, a vote was taken. The decision was made. We would answer. The message was kept simple. Scientists, linguists, mathematicians, and even artists worked together to create it. We used the same prime numbers Atlas had sent us. To show we understood, we included the chemical ratios of Earth. To show we recognized the recipe, we sent the exact coordinates of Earth in the galaxy. To show we weren't afraid to be known, and we included something new, something that was purely human. We sent sounds, not just any sounds. The sound of a baby laughing, the sound of waves on a beach, music, a child singing, an old woman telling a story, wind in trees, birds at dawn. We sent pieces of what makes Earth beautiful, what makes humanity special. The message was transmitted from the largest radio dishes on Earth, aimed at the coordinates we'd found, aimed at that yellow star 47 light-years away. I was there when we sent it. standing in the control room with Sarah, Alex, and Professor Wright, with Director Chen and Dr. Patel and Dr. Tanaka and all the others who'd worked so hard. When the technician pressed the button to transmit, everyone held their breath. The message traveled at the speed of light. It would take 47 years to reach its destination. None of us would be alive to hear a response if one came, but we'd done it. Humanity had spoken to the stars, and the stars had answered. We weren't alone. After the message was sent, we waited. We knew we wouldn't hear a response for 94 years at minimum. 47 years for our message to get there, and 47 years for their response to come back. That's if they answered immediately. But something strange started happening right away. 3 days after we sent the message, our instruments detected something odd. Nothing big, nothing obvious, just a distortion in the background radiation of space. It was like a ripple, like when you drop a stone in a perfectly still pond and circles spread outward from where it landed. "What is that?" Sarah asked, staring at the data. "I don't know," I admitted. "It's coming from the direction where we sent the message, but it can't be a response. It's too soon. The signal couldn't have gotten there yet." Alex was running calculations. "Unless, what if there's something between us and them, like a relay station, something that received our message and is acknowledging it?" We brought the data to Director Chen. She assembled a team to study the anomaly. For 2 weeks, we watched. The ripple effect continued. Then, slowly, it faded. "It's like space itself bent," Dr. Tanaka said one evening. We were all exhausted, sitting around a table with cold pizza and warm soda, like something massive moved or shifted position. "Or like something was listening," I said quietly. And when we spoke, it noticed. Professor Wright removed his glasses and cleaned them, which he always did when he was nervous. "The universe is stranger than we thought, Marcus. Much stranger." While we studied the ripple, the world outside was changing. People weren't scared anymore. They were excited, hopeful. Schools started teaching more science. Kids everywhere wanted to be astronomers and physicists. Applications to space programs increased by 400%. Countries that had been enemies started working together. "If aliens exist, we're all just humans," one world leader said in a speech. "Our differences don't seem so important anymore." Artists painted the night sky. Musicians wrote songs about the visitors. A famous poet wrote a piece called The Messengers that made me cry when I read it. Religious leaders from different faiths came together. Some said the visitors proved we were part of God's greater creation. Others said it challenged their beliefs but made them think deeper. Most agreed that the universe was full of mystery and wonder. Not everyone was happy, of course. Some people insisted it was all a hoax. Some people were angry that we'd sent a message without asking every single person on Earth. Some people thought we'd made a terrible mistake. But most people? Most people felt something they hadn't felt in a long time. Hope. Hope that we weren't alone. Hope that intelligence existed beyond Earth. Hope that maybe, just maybe, there were friends out there among the stars. 6 months after Atlas left our solar system, Project Messenger started winding down. We'd learned everything we could. We'd sent our response. Now we just had to wait, for decades, maybe for centuries. Some scientists went back to their universities, others moved on to new projects. Director Chen started planning a long-term program to keep listening for signals, just in case something else came. I was offered jobs at universities around the world. I could write books, give lectures, become famous, but I didn't want that. What I wanted was to keep searching, keep listening, keep watching the sky. So I took a job at a small observatory in Chile, high in the mountains where the air is thin and the stars are so bright they look close enough to touch. Sarah came with me. So did Alex. We became a team again, just the 3 of us, looking up at the night sky every clear evening. Professor Wright retired but visited often. He'd sit with us, drinking tea, telling stories about his youth when he first fell in love with space. One day, a school bus arrived at our observatory. 20 kids, about 9 or 10 years old, poured out with their teacher. They were studying ʻOumuamua and Atlas in class and wanted to see a real observatory. I gave them a tour, showed them our telescopes. let them look through the eyepiece at Jupiter and Saturn and Mars, but what they really wanted to talk about were the visitors. "Do you think they'll come back?" a little girl with glasses asked. "I don't know," I said honestly, "but I hope so." "Are you scared of aliens?" a boy asked. I thought about that. Sometimes. But mostly, I'm curious. I want to meet them. I want to ask them questions. I want to know what their world is like. "What if they're mean?" another kid asked. "What if they're nice?" I answered. "What if they're just like us, curious, hopeful, looking for friends?" At the end of the tour, the teacher had the kids sit in a circle. She asked them to draw pictures of what they thought the aliens looked like. Some kids drew little green people, others drew giant brains. One kid drew what looked like a floating jellyfish made of light, but one little girl drew something different. She drew Earth and another planet, with a line connecting them, and on the line, she drew a heart. "What's this?" I asked her. She looked up at me with serious eyes. "That's us saying we want to be friends." I had to turn away because my eyes were getting wet. That little girl understood. That's what this was all about. Not about fear or war or danger, about reaching out, about saying we're here and we want to know you. 1 year after Atlas left, something happened that no one expected. I was at the observatory late at night. Sarah and Alex had gone to bed. I was alone doing routine observations when one of our radio telescopes picked up something strange. A signal, brief, only a few seconds long, but it was coming from the direction of Oumuamua's path. Or rather, where ʻOumuamua would be if it had continued on its trajectory. My hands shook as I checked the instruments. Was I imagining this? Was I so obsessed that I was seeing patterns that weren't there? I recorded everything. Then I called Sarah and Alex. "Please tell me you see this too," I said when they arrived, still in their pajamas. Sarah looked at the data. Her eyes went wide. That's a signal. A real signal." Alex started analyzing it immediately. "It's weak. Very weak. And Marcus, it's using prime numbers again, just like Atlas." We couldn't believe it. Oumuamua had left our solar system in 2017. It should be impossibly far away now. Too far for us to detect any signal. Unless it had turned around. Unless it was coming back. Or unless there were more of them. Many more. And they were communicating with each other. And we were just now learning to listen to their conversations. We spent 3 days analysing the signal. We shared our data with other observatories around the world. Everyone confirmed it. The signal was real. But where was it coming from exactly? And what was it saying? Dr. Tanaka from Japan was the one who figured it out. He called us on a video chat, his face excited. "I've triangulated the signal source. It's not from Oumuamua. It's from somewhere between Oumuamua's last known position and the coordinates we found in Atlas's message." "What does that mean?" I asked. "It means," Dr. Tanaka said slowly, "that there might be others out there, maybe many others, traveling between stars, talking to each other, and now that we've announced our presence, they're noticing us." The implications hit me like a wave. What if interstellar space wasn't empty? What if there were thousands, maybe millions of objects like Oumuamua and Atlas, traveling between stars, carrying messages, spreading life? What if there was a whole network out there, a galactic communication system that we'd just barely started to detect? What if we weren't discovering aliens, but being discovered by them? Over the next 6 months, we detected 4 more signals, all brief, all using prime numbers or mathematical constants, all from different directions in space. Other observatories detected signals too. China picked up 2, Europe detected 1, a telescope in Australia found another. Scientists around the world started mapping them, where they came from, when they appeared, what they might mean. And slowly, a pattern emerged. The signals were all roughly the same distance from Earth, about 40 to 50 light years away, forming a rough sphere around our solar system. "It's like a boundary," Sarah said, staring at the map we'd created. "Or a zone. Or a quarantine," Alex added darkly. Professor Wright, visiting from his retirement home, studied the map for a long time. Then he said something that made us all go quiet. "Or it's like a neighborhood." and we just moved in, and all the neighbors are introducing themselves. The United Nations held a special assembly. Every country sent representatives. Scientists, including me, were invited to present our findings. I stood at a podium in front of hundreds of people, with cameras broadcasting to billions around the world. I was terrified, but I had to speak. For all of human history, I began, we believed we might be alone. We looked at the stars and wondered if anyone looked back. Now we know we're not alone. We've never been alone. I showed them the data, the signals, the patterns, the map of potential sources. We believe these are markers, beacons, a network of communication spanning many light years, and Earth is right in the middle of it. A representative from Brazil asked, "What do they want from us?" "I don't think they want anything," I said. "I think they're just acknowledging us, the way you might wave at a new neighbor moving in next door." "But why now?" someone from Russia asked. "Why not 100 years ago? Or 1,000? I thought about this a lot, because now we can hear them. 100 years ago, we didn't have radio telescopes. We didn't have the technology to detect these signals. They've probably been here all along. We just couldn't listen. "So what happens next?" asked a representative from Kenya. I took a deep breath. "That's up to us. We can choose to listen more carefully, build better instruments, try to decode more messages, or we can choose to stay quiet, to observe but not engage." "What do you recommend?" Director Chen asked. She was sitting in the front row. I thought about that little girl's drawing, Earth and another world connected by a heart. I think we should listen. I think we should learn. And when we're ready, I think we should talk. Not with fear, but with curiosity and friendship. Not all scientists agreed with me. Some thought we were seeing patterns that weren't there, that we were so desperate to find intelligence that we were making up meanings that didn't exist. It could all be natural, one famous scientist argued in a debate. Electromagnetic phenomena, magnetic fields, solar winds interacting with interstellar dust. We're seeing faces in the clouds, but more and more evidence kept appearing. The signals were too organized, too mathematical, too purposeful. Other scientists worried about danger. What if we're like ants discovering humans? A physicist from Germany said. What if they're so far beyond us that we're just irrelevant, or worse, in the way? Professor Wright responded to that in a lecture I watched online. If they wanted to harm us, they've had plenty of time. These signals suggest they've known about us for decades, maybe centuries, and they've done nothing but say hello. There were philosophical questions too. What does this mean for humanity? Religious leaders asked. What is our purpose if we're just one civilization among many? Maybe our purpose is the same as it's always been, a wise teacher from India said. To learn, to grow, to love, to create. But now we know we're doing it as part of a larger community. 2 years after ʻOumuamua first arrived, I took a vacation. I went back home to where I grew up, a small town in Oregon. I visited my old school, walked the streets I'd walked as a kid, looked up at the same sky I'd gazed at when I first fell in love with space. Everything looked different now. The stars didn't seem so far away. The universe didn't seem so empty. I thought about that night in 2017 when I first read about ʻOumuamua, how excited I'd been, how curious. I thought about all the years of work, the sleepless nights, the frustration and the breakthroughs. I thought about what we'd learned, and I realized something important. The messengers, ʻOumuamua, Atlas, and all the signals we'd detected, they weren't really about aliens at all. They were about us. They were a mirror showing us who we are and who we could be. When we saw ʻOumuamua, some people saw threat, others saw wonder. What we saw depended on what we brought to the looking. When we heard the signals, some people heard danger, others heard invitation. What we heard depended on whether we listened with fear or hope. The universe wasn't testing us. It was offering us a choice. We could stay small and scared, hiding on our little planet, afraid of what might be out there, or we could grow up. We could accept that we're part of something bigger. We could reach out with open hands instead of clenched fists. The messengers didn't change the universe, they changed us. I'm older now. My hair is turning grey. I've spent most of my adult life studying these visitors and signals. We still haven't received a clear response to our message. That yellow star is 47 light-years away, remember? Our message hasn't even arrived yet, but that's okay. We've learned patience. We've learned that the universe moves on timescales much longer than human lives. That's not a bad thing. It's just the way it is. We've built better telescopes, better computers, better ways of listening, and we keep detecting signals, not often, maybe once every few months. Sometimes we go a year without hearing anything, but they're out there. The messengers, the travelers, the beacon keepers, and we're learning their language, slowly, one prime number at a time, one mathematical constant at a time. Sometimes I give talks at schools. Kids always ask the same questions. Will we ever meet aliens? Maybe. Probably not in my lifetime, maybe not for hundreds of years, but someday I think yes. Are you still scared? Sometimes. The unknown is always a little scary, but mostly I'm excited. What's the most important thing you've learned? That's easy. I tell them the same thing every time. I learned that we're not alone. I learned that the universe is full of intelligence and wonder. And I learned that reaching out, even when you're scared, even when you don't know what will happen, is always better than staying silent. These days, I split my time between the observatory and teaching at a university. I have students from all over the world who come to study with me. They're brilliant, more brilliant than I was at their age. They grew up in a world that knows aliens exist. They don't question it, they accept it and build on it. One of my students, a young woman named Kenji from Japan, is working on new ways to decode potential alien mathematics. She's created programs that can recognize patterns humans might miss. Another student, Marcus Jr., his parents named him after me, which is both flattering and embarrassing, is studying exoplanets, planets around other stars, trying to figure out which ones might host civilizations that could be sending messengers like ʻOumuamua. Do you think they're all connected? Marcus Jr. asked me one day. All the civilizations out there? Do you think they talk to each other? I think they're trying to, I said. These messengers, they're slow. They take thousands or millions of years to travel between stars. But maybe that's the point. Maybe patience is the first requirement for joining the galactic community. It happened in my 60th year. I was getting ready to retire, planning to write a book about everything I'd learned. Then the alerts started. Interstellar object detected. This time I wasn't surprised. I'd been expecting it. The third visitor was different from the first two, smaller, faster, and it was sending signals from the moment we detected it. We called it 3I/messenger, because by now we understood what these objects were. They were literally messengers, carriers of information, bottles thrown into the cosmic ocean, hoping to find shores on distant worlds. This one was coming in fast, and its trajectory was unusual. It wasn't just passing through our solar system, it was slowing down. It's using the sun's gravity to brake, Sarah said. She was grey-haired now too, but her eyes were as sharp as ever. Marcus, I think it's trying to stay. My heart raced. Stay? Here? In our solar system? We watched for weeks as 3I/messenger adjusted its course. It settled into an orbit between Mars and Jupiter in the asteroid belt. It was positioning itself, like a satellite, like a permanent beacon. The signals it sent were the clearest yet, mathematical formulas, chemical compositions, and something new, images, not photographs, but data that could be converted into images. Simple ones, a circle, a star, a spiral that might represent a galaxy, and then an image that made us all gasp. 2 circles, one smaller, one larger, and a line connecting them. That's us, Alex whispered. He was retired but had come back to help with this new visitor. That's Earth and them, that's connection. The third visitor was an answer. Not to our message sent 2 years ago, that was still traveling through space, but an answer to our existence, our presence, our willingness to listen. World leaders gathered again, scientists debated, people everywhere discussed what this meant. The third visitor was staying, orbiting our sun, sending signals constantly. It was like someone had moved next door and was constantly trying to start a conversation. "We need to decide," Director Chen said. She was older too, planning to retire soon. "Do we just observe, or do we respond?" "We already responded," I reminded her. 2 years ago, we sent our message. But that was to a star 47 light years away. This is different. This visitor is here, now, waiting. The debate was fierce. Some people wanted to send a probe to 3I/Messenger, to get close, to study it directly, maybe even to touch it. Others wanted to be cautious. What if approaching it is seen as aggressive? What if we trigger some kind of defense mechanism? Young Marcus Jr. had an idea. What if we send a simple mathematical response? Nothing aggressive, just acknowledgement. We could beam radio signals directly at it, prime numbers, the same ones it's sending us, to show we understand. It was a good idea, simple, safe, friendly. The decision was made. We would talk to our visitor. On a clear night in March, every radio telescope on Earth pointed at 3I/Messenger. We sent our message, prime numbers 2, 3, 5, 7, 11, 13, then we waited. 3 hours later, the visitor's signals changed. It sent back our prime numbers. Then it added more, 17, 19, 23, 29. It was continuing the sequence, like a call and response, like a conversation. I sat in the control room with tears running down my face. Sarah was crying too. Alex was laughing and crying at the same time. Professor Wright, watching from his nursing home via video link, simply smiled. "I knew it," he said softly. "I always knew. We were talking. Humanity and another intelligence. Across the darkness of space, with numbers and patterns and patience. It wasn't like the movies. No spaceships landing, no dramatic encounters, just communication, connection, but it was the most beautiful thing I'd ever experienced. Over the following years, our conversation with 3I/Messenger continued, slowly, carefully. Both sides are learning. We learned that the visitor wasn't controlled by an alien sitting inside. It was automated. A machine, an artificial intelligence probably, sent long ago to travel between stars and make contact when it found intelligent life. We learned that the prime numbers and mathematical constants were a universal language. Math works the same everywhere in the universe. It's the perfect way to say, "We're intelligent," to someone who doesn't speak your language. We learned that the chemical recipes we'd seen weren't instructions for making planets. They were signatures, ways of saying, "This is what our world looks like," and asking, "What does yours look like?" Most importantly, we learned something about the civilizations sending these messengers. They were patient. These objects took thousands or millions of years to travel between stars. Whoever sent them knew they might never see the results. They were planting seeds for future generations. They were peaceful. The visitors carried no weapons, posed no threat. They were only tools for communication. They were hopeful. Despite the vast distances, despite the incredible timescales, they kept sending messengers. They kept reaching out. They never stopped hoping for connection. And we learned something about ourselves too. We learned that we could be patient. We could work together. We could set aside our differences for something greater. We learned that we were braver than we thought. Brave enough to say hello to the unknown. Most importantly, we learned that hope is worth it. Even when answers take a lifetime, or many lifetimes, hope is worth it. I'm retiring for real now. I'm 70 years old. My knees hurt. My eyes aren't as sharp. It's time for younger people to take over. On my last night at the observatory, I stood outside under the stars. Sarah and Alex stood with me. We didn't say much, we didn't need to. We looked up at the sky, at the countless stars, and thought about everything we'd seen and learned. "Do you think we'll ever meet them face to face?" Sarah asked. "Maybe," I said. "Probably not us. But humans someday, maybe in 100 years, maybe in 1,000. "Was it worth it?" Alex asked. "Your whole life studying these visitors?" I thought about that question. I thought about all the sleepless nights, the frustration, the doubt, the fear. But I also thought about the wonder, the discovery, the moment when I realized we weren't alone, the moment when we first talked to another intelligence. "Yes," I said, "every second was worth it." In my office, I've left something for future students, a letter, a time capsule of sorts. It says, "Dear future scientist, if you're reading this, then you've chosen to study the visitors, the messengers from beyond our solar system. Good. We need curious minds like yours." When I started this journey, I was young and full of questions. I'm old now, and I have even more questions. That's how science works. Every answer leads to new questions. But here's what I know for sure. We are not alone in the universe. Life exists beyond Earth. Intelligence exists beyond humanity. And somewhere out there, maybe many places, there are others looking up at their sky and wondering the same things we wonder. The messengers, ʻOumuamua, Atlas, and all the others we've detected, they're not just objects. They're hands reaching across the darkness. They're voices saying, "We're here." They're hopes that someone might answer. Your job, future scientist, is to keep listening, keep learning, keep reaching back. It won't be easy. You'll work long hours, you'll face setbacks, people will doubt you, you'll doubt yourself sometimes. But remember this, every great journey starts with a single step. Every great conversation starts with a single word. ʻOumuamua was that word. Scout, messenger, hello. Keep the conversation going. For all of us. For all of humanity. And maybe someday, generations from now, humans will travel to that yellow star 47 light years away. They'll meet whoever lives there. They'll shake hands or tentacles or whatever they have and say, "Thank you for reaching out." And it will all start with the work you do today. Keep looking up, keep listening, keep hoping, with admiration and faith in your generation. Dr. Marcus Reed. On my last day at the university, I gave one final lecture. The auditorium was packed. Students, faculty, even some people from town who'd heard about my retirement. After the lecture, during questions, a little girl in the front row raised her hand. She couldn't have been more than 8 years old, there with her parents. "Yes," I said, smiling at her. "Mr. Reed, when the aliens come to visit, will you be there?" My heart melted. "Probably not, sweetheart. I'll be too old. But you might be there. You could be one of the people who meets them." Her eyes went wide. "Really? Really? If you study hard, if you stay curious, if you never stop asking questions." Another student, one of my graduate students, asked, "What's your greatest hope for the future?" I thought about that. There were so many things I hoped for. "My greatest hope," I said slowly, "is that we remember this feeling, this moment in history when we learned we weren't alone. I hope we remember the wonder, the excitement, the hope." I paused, looking around the auditorium at all those faces, young and old, from every continent, every background. I hope we remember that we're all human, that compared to the vast universe, our differences are tiny. And I hope that when we finally do meet our neighbours among the stars, we greet them not with fear or weapons, but with open hearts and curious minds. The applatorium erupted in applause, but I wasn't done. "And one more thing," I added. "I hope that when they ask us, 'What is humanity like?' we can say, 'We are a species that looked into the darkness and chose to hope. We are a species that heard a message and chose to answer. We are a species that, despite all our flaws, never stopped reaching for the stars.'" 50 years have passed since ʻOumuamua first arrived. I'm an old man now, living in a small house near the ocean. I can't see the stars as well as I used to, but I still look up every clear night. The world has changed so much. We've detected 17 more visitors. Each one is different. Each one teaches us something new. We've built new telescopes that can see further than ever before. We've sent our own messengers, small spacecraft carrying information about Earth, traveling toward nearby stars. And most importantly, we've changed as a species. Not completely. We still have problems. We still fight and disagree. But we've also come together in ways we never did before. The knowledge that we're not alone, that we're part of a larger cosmic community, has given us perspective. Yesterday, my great-granddaughter visited me. She's studying astrophysics at university. Following in her great-grandfather's footsteps, she says, "Tell me again about the first time," she asked. "About ʻOumuamua." So I told her, the same story I've told 100 times, about the strange object, the mystery, the questions. Were you scared? She asked. Yes, I admitted, but I was more excited than scared, more curious than afraid. That's how I want to be, she said. If you're reading this story, young reader, then you're living in the time after the discovery, the time when humanity knows it's not alone. Remember this, the messengers, ʻOumuamua, Atlas, and all the others, they weren't sent to scare us. They weren't sent to test us or judge us. They were sent to connect us. Maybe ʻOumuamua was a question, is anyone there? Maybe Atlas was confirmation, yes, we see you. Maybe the third visitor and all the ones after are the beginning of a conversation that will last thousands of years. What comes next depends on you, your generation, the choices you make. Will you listen with fear or with hope? Will you reach back with clenched fists or open hands? Will you see the universe as a dangerous place to hide from or an amazing place to explore? I believe in you. I believe you'll choose hope. I believe you'll choose curiosity. I believe you'll choose to join the great conversation happening among the stars, because that's what humans do. We reach out, we connect, we hope. The universe is full of silence, but it's not empty silence. 'Tis the silence of listening, the silence of waiting, the silence of possibility. And maybe, just maybe, the silence is full of friends we haven't met yet. Friends who are also looking up at their sky, also wondering, also hoping. Friends who sent messengers to say, we're here, where are you? And we answered, we're here too. Hello, the universe has spoken, and so have we. What happens next is up to all of us. Keep looking up, keep listening, keep hoping, because we are not alone. We never were. They weren't here to invade. They came to see if we're ready, ready to join the silence between stars, the silence that listens, the silence that hopes, the silence that waits for us to say, we're ready. Let's talk.